Hello, algebra, hopefully. It's 2 o'clock on Tuesday. He's chewing on a rope. And we're going to talk about some math. So I had some issues with the stream for the 1 o'clock geometry class, so hopefully that doesn't happen again. Otherwise, we might just... We'll see. Everything should be working fine as far as I can tell. Yeah, and we're going to work on chapter 9. Okay. So I need to get this open on my other computer so I can read the chat. Yeah, perfect. Okay. And this. Okay. Yeah, perfect. All right. And yeah, we're going to be talking about chapter 9. I put some stuff in the Dropbox. So I put the chapter summary in the Dropbox, and I put the I'm blanking, student journal pages in the Dropbox for chapter 9. And so chapter 9 is, that's the wrong button. This. Excuse me. So chapter 9 is about trigonometric ratios and functions. So this is sine, cosine, and tangent. And we'll be talking about those more in detail as the chapter goes on. You should have seen these in geometry towards April in geometry, around April, or now in geometry. So last year, if you were in geometry, hey, last year in geometry, you should have seen sine, cosine, and tangent, and done some right triangle solving with those, as well as solving for angles using their inverses. Okay, so in algebra 2, we're going to focus more on, we'll do those things as well, but we're also going to focus on what the graphs of the functions look like, and how the curves of those graphs operate, and we're also going to talk about the unit circle and different ratios there. Okay, so this chapter summary, which is a bit blurry on the screen, I'm seeing, is a PDF in the Dropbox. We need that. It's in the Dropbox. Okay. And we're going to get to stuff down here. This top section right here under core concepts. This stuff is what we'll be doing, focusing on today. And then later on, we'll get to this unit circle with special angles. And we'll get to radians, which we didn't cover in geometry, most likely, but we will cover here. Okay. So, to start, we're going to switch to this thing. Okay. We're going to talk about our trig functions. So there's a bunch of these. And we're going to be solving right triangles today. And I may go kind of quick because this is all review from geometry. 16 subs away from Bridgerville. Yeah, tell your friends. Okay. And so the main ones for this, for solving right triangles, are going to be sine, cosine, and tangent. And if you have a calculator, they say sine, cosine, and tan, like this, right? Sine, cos, tan. Okay. And we put numbers in those things, and they spit out another number. So I'm going to switch to this. Okay. And before we talk about how those work with the right triangle, I just want you to see the functions in Desmos. So we would have done this in class. If you go on Desmos and you just type in sine, it'll switch it to this kind of more vertical font instead of the italicized font. And we would do sine of x And that's the sine function. So it goes up and down, its curve goes on forever and ever and ever and ever and ever. Right? And it never gets bigger than 1. So this height right here is 1. And we'll talk about pi over 2 and how that works in radians later. I really wish my video wasn't covering that. There we go. And then we could do cosine of x. Cosine of x is just sine of x shifted over. Alright, so when we're looking at this here, if I took that red sine of x here and I shifted it over to here, it's the same function, curve. Okay, and then if we divide them, sine x divided by cosine x, we get this thing, which is the same as tan x. So tangent of x, this vertical kind of wavy thing, is a combination of sine and cosine. Right? And cosine is really just the sine function shifted over. So this is just the sine function divided by another form of the sine function. Okay, so our three together look like this. I'm not really going to graph all three of them like that at the same time. Those are the three. Yeah, what they look like. All right. Go back to this thing. So sine, cosine, and tangent. There are inverses for each of these, but you put an angle in here. Theta is our angle, and these are going to equal something in the right hand. And we have a phrase to remember what they equal. So, and so this is the thing that hopefully you remember from geometry. We're going to use the sine of whatever the angle is the opposite side divided by the hypotenuse. And cosine is adjacent divided by the hypotenuse. And tangent is opposite over adjacent. Okay, so we create these ratios. Okay, and the way we would use those ratios, I'm going to erase some stuff and redraw it. The way we would use each of these is in our right triangle. Here's our 90-degree angle. Here's our theta. The opposite side is the side across. The adjacent side is the one next to it. And the hypotenuse is, of course, the longest hypotenuse of. So opposite over there and adjacent there. And it's relative to theta. If theta was up here, this was theta, this would be the opposite side, this would be adjacent, this would be the hypotenuse. Still. Okay, so opposite is across from the angle. Adjacent is next to or touching whichever angle we're looking at. Okay. So we can use this to find pieces of angles, pieces of triangles. Okay. And our key phrase is going to be so. Okay, I would tell you to memorize that on a test, and as soon as you're taking the test, to write this on the test, this thing, to remember it. But we won't have a test, so we don't need to do that. Let's do some examples of how these actually work. Okay. So instead of making up some numbers, we'll grab some textbook ones. Okay, so if we go back to the screen, here's our book. Okay. Now, if there's some extra ones, we'll add these in a minute. But you can see here, sine. Oh, wait, switch. There we go. You can see here, this is in your textbook on page 462. You can see sine, cosine, and tangent. Okay. And we'll talk about cosecant and all those things. Okay. So we have this triangle. I'm just going to draw the triangle that's in the book. We draw it. It's right triangle. So we have theta up here. This is 5, this is 12, and this is the hypotenuse. Yeah. Okay. So we could use the Pythagorean theorem to find the hypotenuse. The h squared equals 5 squared plus 12 squared. We could do it that way, right? A squared plus b squared equals c squared. That's Pythagorean theorem. We're not going to do that. We're going to use sine, cosine, or tangent. So sine of our angle, which we don't know what it is equal to opposite. So how far is it? So so we're going to use this opposite over hypotenuse. So it'd be 12 over whatever the hypotenuse is. Cosine of our angle, whatever that is going to be adjacent over hypotenuse. That's going to be a 5 over h. And then tangent, theta, is going to be opposite over adjacent. TOA, opposite is, oops, not L. Opposite is 12 over 5. So here, this is the only one for this problem that doesn't have two variables in it. This theta is a variable, we don't know what it is. So these two numbers, we can solve then for theta using an inverse. Okay? So what we would do is we would do tan inverse. Well, actually, I don't want to get into that. And that would give us theta. I don't really want to get into that quite yet. Okay? But we take the ratios, we look at the angle, we do opposite over hypotenuse, adjacent over hypotenuse. This is how we set up our fractions. Okay? I think in the book they solve for whatever the hypotenuse is. Yeah. Okay. So that's sine, cosine, tangent for that triangle, those ratios. The other ones that we're going to focus on, which get used less, but when you get higher up in math, maybe just more, are cosecant. So we have sine, cosine, tangent. The other ones we would use, the new ones we're adding that we didn't talk about in geometry, are secant, cosecant, and cotangent. Co means with, so it's similar. And these are just 1 over sine, 1 over cosine. This is 1 over tangent. Or you can think of them as secant I got that backwards. Scratch that. That's completely backwards. These are mixed up. Sorry, I mixed those up. It's been a while. So cosecant goes with sine, and secant goes with cosine. Yes, so I got that wrong. Okay, so each of these is 1 over the original 6 functions. And so we can think of these as, here we would say, so TOA for these 3. For these, there's not going to be a phrase to remember them because it's just the inverse. But we would say cosecant is hypotenuse over the opposite. And secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. It's the opposite of what we have here, so they're backwards, or they're inverted. Okay. Okay. So the thing that we need to do is evaluate the trig ratios. This is not really how to do this. Special ones, which I'm going to talk about next. Okay, so here's how we're going to solve the right triangle. Okay, so you need two pieces of information to solve a right triangle. Here's our right triangle. Here's the angle we're going to use, and we'll just do a 3 and a 4 here, and we'll figure out this hypothesis. Okay. Each of these trig functions has an inverse that lets you find angles. So inverses find angles. Trig functions find sides. So we have two sides here. We want to find this third side, which we could use the Pythagorean theorem. We're going to use trig function to do that. And then we have we have these two angles we want to find. Okay, so first we need to find theta. So we're going to use, this is theta here, this is the opposite side, this is the adjacent side. So we're going to use tangent of theta is opposite over adjacent. To find theta, we would do tan inverse, which is a tan with a -1 on it, on both sides. Okay? And then these cancel out. This tan inverse of this tangent cancels out. And so we get theta equals tan inverse of 4 over 3. Hopefully you remember this from geometry. Hopefully. Okay? So to solve that, we would go to Desmos. And we're not going to use these things. We're going to go to use a little keyword to do that. Inverses, functions. If you click functions, which is hidden by my picture here, all the trig functions show up, and we don't have to tan with a -1 like that. Okay, and so we do 4 divided by 3 inside of there. And so that would be degrees. The radians. So we get 53.13 degrees. Okay, and so we're going to do degrees for now, and we'll get to radians. Okay, so 53.13 degrees. That's the angle. Now to find the other angle, we would do 90 minus 53.13. Because that's going to give us this angle up here. So that's, I don't know, 47? 37? So we could do just 90 minus Desmos. 90 minus that thing, and that gives us the degrees. So 36.86 degrees. So two angles. So we know this angle is 53. We know this angle is 36. 37. Okay? And then to find the hypotenuse here, you could use the Pythagorean theorem, because you know two sides. Or you could use any of the other trig functions. I'm going to erase this work, except for the angle measures, because we need some space. So those are our two angle measures. We want to find h here. So there's a number of ways we can do that. We're going to use the angle and one of our trig functions. So I could use sine. Sine of 53.13 is going to be opposite over hypotenuse. That would be 4 over h. Opposite over hypotenuse, right? Because it's so. We could do cosine 53.13 is going to be the adjacent side over the hypotenuse. That's going to be 3 over h. Or tangent doesn't work, it doesn't use the hypotenuse. So you'd use one of those, and then you just need to solve for the variables. So let's use the sine one here. We could use cosine. We're going to use sine. We need to get h out from the bottom, so we're going to cross multiply. So we get h sine 53.13 equals 4. We cross multiply. It's the variable on the top over here. And then we would divide by sine 53.13 on both sides. And remember, sine is not a variable. It's a number when it has a number inside of it. It's a function, so when we put something inside of sine, we get a number out. So here, we're going to get h equals 4 divided by sine 53.13, which is, yeah, run out of room on the whiteboard. We need to divide 4 by sine of 53.13. It goes on for a long time. So it's basically 5. Now, we rounded here. This 53.13 is rounded. It's not exactly the right amount of degrees. So this should be 5. Okay, so to solve the right triangle, to solve the right triangle, we find all the sides, find all the angles. Okay. And you just use different pieces of the triangle to find the missing pieces using sine, cosine, tangent. You did a lot of this in geometry. We did this in geometry. So that's partially why I'm kind of going through this section very quickly. The student journal is super helpful for this section because if you look at the student journal, it's got this picture nicely labeled with the degree, the theta. It's got the adjacent side, the opposite side, the hypotenuse, and that's all relative to the theta here. You can't use the 90, the hypotenuse is always the side across from the right angle. And then it talks about what sine, cosine, tangent, secant, cotangent, all those things are. Okay? Then, also in the student journal, got some vocab here. It lists all these again. And then it's got a really fancy table for some important values. We'll get to these later when we talk about the unit circle. Why you want to do those here. Okay. And then we got some practice problems. So I'm going to do one from each of these sections here, I think. Yeah. Okay, so it says evaluate the 6 trig functions for angle theta. So one is evaluate the 6 trig functions. We're not finding theta. All we need to do is evaluate the functions, which means, here's my really poorly drawn right triangle. We want to know what sine of theta equals. We want to know what cosine of theta equals. We want to know what tan of theta equals. We want to know what cosecant is CSC of theta equals. We want to know what secant of theta equals. We want to know what cotangent equals. Okay, so we're using SOHCAHTOA to help us remember what each piece does. Here, SO is opposite over hypotenuse. Opposite over, we don't know the hypotenuse. We need to find the hypotenuse. Find the hypotenuse, you can, how do we do that? It's the one way we just did, where you solve the right triangle, or you can use the Pythagorean theorem. So h squared is 8 squared plus 15 squared. So h is the square root of 8 squared plus 15 squared. We'll plug that into a calculator. Square root of, square root of 8 squared plus 15 squared, 17. So h here is 17. Okay, so h is 17. And then we will use 17 for the h and so. So sine of theta is going to be opposite 15 over 17. And this is always going to be smaller than 1. The hypotenuse should always be bigger. Same for cosine. Cosine is going to be adjacent over hypotenuse, 17. Tangent is going to be opposite over adjacent. Tangent could be bigger than 1 or smaller than 1. It just depends. Okay. Opposite over adjacent is 15 over 8. So opposite side and adjacent side. So this angle, we're not looking at this angle, we're looking at the angle up there. Cosecant then is going to be this flipped over. It's going to be hypotenuse over adjacent, or opposite. And secant is going to be hypotenuse over adjacent. And cotangent is going to be adjacent over opposite. So it's these things flipped. Okay? So that's how we'd solve the ratio. So the problem for the student journal was evaluate the 6 trigonometric functions of the angle. Didn't say find the angle, just said evaluate functions. So we would get these 6 ratios here. And I would leave them like this. You don't need to plug it into the calculator and simplify 8 over 15. Just leave it like that. Okay? Now, in exercise 3 and 4, let theta be an acute angle of a right triangle by the other 5 trig functions of theta. Now, all they give us is tangent of theta. Tangent of theta tells us a lot, actually. This is tan theta equals 1. Okay, so we have a right triangle. Okay. Tan of theta is 1. Now, doesn't matter which angle is theta. Could be this one, could be this one. I'm just going to make it out because it's easier for me to see. Okay. And then tangent is opposite over adjacent. This is our opposite side. This is our adjacent side. Relative to theta, right? Opposite and adjacent. So we need 2 numbers that divide, when divided, equal 1. Now there are a lot of numbers when divided equal 1. But we don't need to pick all the numbers. We just need to pick the simplest one. And the simplest one is 1 over 1. 1 over 1. You could have picked 2 over 2, 3 over 3, 4 over 4. They would all give you the same ratios, right? Because when we simplify them for this right here, we're trying to find the other ratios. They'll simplify to the simplest thing. If we have bigger numbers here, they'll still simplify small. Okay. So now we need to find just the hypotenuse, and then we can write all the functions again. Sine, cosine, tangent, secant, cosecant, cotangent, or cosecant, secant. Okay. So what we're going to do is find h. H is the square root of 1 squared plus 1 squared. So h is the square root of 2. And I'm going to leave it like that. I could write this as a decimal and plug it in the calculator, but I'm just going to leave it like this. Okay? Now, sine of theta equals cosine of theta equals tangent of theta equals 1. We know that. And then cosecant of theta equals secant of theta equals cotangent of theta equals. So cotangent is just 1 over 1. So 1. Sine of theta is going to be opposite over hypotenuse, so it's going to be 1 over square root of 2. Cosine is going to also be 1 over the square root of 2. They're the same. It's nice houses, right triangles, so definitely the same. And then here we would flip this over. It would be the hypotenuse over opposite, so it's square root of 2 over 1, and this is square root of 2 over 1. Now, we'll talk more about this. And we wouldn't really want to leave this as 1 over the square root of 2. There's a special way to write this, but this is fine for now. Okay. That's that. We can use the fact that we know one of the trig functions to find the other trig functions. So you do the same thing with this one. You have opposite over hypotenuse, 3 over 19. You find the missing side using the Pythagorean theorem, and then you'll be good. Okay? So we're going to do number 5. I'm going to do it that way. Kind of a lot in this lesson, but most of it's review. So I'm not super worried. Okay? And we would have done this very differently in class, of course. So we have a right triangle. 16x here, we have 30. Find the value of x for the right triangle. So we have an angle. This is theta. We want to find the adjacent side, and we know the hypotenuse. So we look at our phrase, SOHCAHTOA. I'm like, okay, which one of these has an adjacent side and a hypotenuse? Which one has an A and an H? Well, cosine, CAH, cosine of theta equals adjacent over hypotenuse. Switch screens. Sorry. So I have my right triangle. Looking at theta is 30. Which one from our phrase SOHCAHTOA has an adjacent side and a hypotenuse in it? Because 30 is adjacent to the x. That'd be ka. So we use cosine. So cosine of theta equals over h. So we would get cosine of 30 equals x. 16. Excuse me. X over 16. Because the angle is 30, theta is 30. X of the adjacent side, 16 is the hypotenuse. So then, to solve that, so you get x by itself. So multiply both sides by 16. So we get 16 cosine 30 is x, and we plug that into our calculator, and it gives us side length. You see my foot? Nice. Still see my feet. All right. Here, so we would go to Desmos, and we would put in 16 cosine 30. So we get x is 13.856. Going on. That's going to go up right now. Okay. That's what x is. And then you're done. We could find the height here, too, using the same kind of method, using the angle and a different trig function. Well, I'll do that. But then that's it for today. Okay? So this isn't part of the problem. What the problem asks for. The problem just said find x. But you can also find y. Using the same information. So we have the angle and we have the hypotenuse. We want to find the opposite side. So to find y, we're going to use sine. So is sine of our angle is opposite over hypotenuse. So sine of 30 equals opposite over hypotenuse. And we just get 16 sine 30. Yeah, I'm on it. It's because the puppy's falling asleep. She's out. So we get 8. 16 sine 30 is 8. And that's it. Okay. So I think that's it for today. You can do the rest of the student journal if you want. Practice problems. This is like a big section in the book. Like 9.1 is really long for some reason. So we can probably split kind of the two things into 2 days. Alright, so your practice from the book is going to be page 466. 5 through 10, and 21 to 26. Okay, so that would be the homework that I would normally assign. And it looks like this book. Here's 467. Yeah, 467 there. These 6, 21 through 26, these ones right here. And then on the previous page. Okay. So that is it for today. A little bit shorter. We didn't do any review. That's it. Turn in the late work. I've been getting emails. I just haven't graded in like the last week. So I will do that this week is the plan. I'll get back caught up. This week. Yeah, I got time excuses. So if you have questions, email me. Remember, you got to show your work. And then if you're doing a test, making up a test, you need to make a study guide, show your work on that, explain things, and then send me what you got on the Khan Academy test. Okay? That's it for today. Good to see about 5 of you talking in the chat a little bit. And we'll be back Thursday, same time. All right. See you guys.